get the back of the car because the back of the car is sticking out there. I only end up using a little bit of the wedge of the rear side. And I don't really care about my left and right. I mean, it's useful, but I really need to know further ahead than anything else. So switching back to a front-facing lens, oh, not to mention, that's just resolution. So the 360 omnidirectional cameras, I highly recommend if you want an omnidirectional camera and you have a specific situation, you should use it. But in my case, I'm going to likely do this stuff in outdoors, so I'm going to have a lot of lens flare. And then also the plastic itself has a fair bit of haze, so everything kind of brightens up. And then there's that unmodeled distortion. We could figure that out. I think this is a solvable problem and something that I would be interested in furthering. But as far as a car is concerned, this was one of those dead ends where I was just like, hey, maybe it's just easier to point the camera forward. Another very simple thing is I immediately ran into situations where I wanted to stop the car. Like there were a number of situations where I wanted to have a Deadman switch and have the car come to a complete stop. DC motors would just coast along. What you really need to do is actually give it a reversing voltage and a reversing current. And I found that the quadrilateral encoders that I just did as just a hack to begin with were certainly not enough divisions to actually create a PID loop for it to come to a complete stop. It would sit there and jerk back and forth, back and forth. And then, because the car has no brakes, didn't have any roll cage either, I ended up flipping this thing and breaking stuff. And I highly recommend, if you're getting into the autonomous car stuff, if you want to go really, really fast, a roll cage is great. Donkey Car has one built in. They know what they're talking about. Another thing that I realized is that the car, I picked it off the shelf. It was something that I had. It was something cheap and available. But if you're building something to race around, likely you want to race around in small, small confined spaces. What you want to do is get the smallest car you possibly can get. And in my case, if I went from a 10th scale car down to a 12th scale car, if I went from a racing car from a racing buggy, I can lower my turning radius, and I can actually train this thing inside of my garage rather than have to go out to that basketball court each and every time. Another thing, just as a racer, I love F1. You want the lowest center of mass as possible. That helps with your vision as well, because you're not going to be tipping one way or the other. The actual car itself is a buggy, and you can hit this thing at speed over speed bumps, and it'll just keep on sailing. Does a great job with that, but as soon as you start doing turns, your whole camera perspective shifts left and right. And that's something that you'll have to handle at some point anyways, but if you can limit it, it's useful. So in my case, when I went to the next car, I wanted a much stiffer suspension, I wanted a smaller car, I wanted a lower center of mass. Also, remote stink. It was great for me, and I think you absolutely should use a remote and actually drive the car. Specifically, if you're trying to get the high-performance version of your car, you're going to have to push it to its limits to kind of understand how you're going to have to develop something against it. So the first one had a remote. The second one, what I realized is that I'm just one dude, and every time that I went to go and do any kind of testing, I would have to get put the laptop down, get the remote, and drive it around, put the remote down, grab the laptop, and see what I did. And what I really wanted is something where I could put the remote entirely aside, and as I'm developing it, have the car drive itself. So I'll talk about that in a second. But the idea is that for the initial development, an outside-in localization technique would be very useful just to get a ground truth of where the car actually is. Versus trying to guess that I drove it 10 feet and I'm going to turn it to the right. If I can get an exact number for it, then I can actually use I can actually build against that. I can build further to the from the inside out tracking that I want to actually build. So Mark II, eBay, your best friend. This particular car is actually relatively expensive. But if you get them used, and if you get them where they've been in a crash, generally the guys that are racing these things want to get rid of them pretty quickly as soon as the next model comes out. So this is a couple models behind the current rev of things. The most interesting thing for me was that it was extremely low to the ground, very stiff suspension, and then it had these little fake brake calipers that I thought were really interesting.
What
Brake rotors.
What brand RC car is this?
This is a Team Associated Apex. You can pick them up. I got this one for a steal off of eBay for less than $80. I think.
Team Associated.
Team Associated.
Disc
Yes,
brakes?
that's correct. Sorry.
Disc brakes?
So yes, these are fake disc brakes. But when I saw these, I was agog because that's where I can put my encoders. Come to that in a second. So one of the things was that I wasn't so happy about having two power supplies, and specifically I wanted the car to come to a complete stop as soon as the Deadman went active. So I went down and was looking around at brushless DC motors, and there's an open source ESC called the VESC, made by Benjamin, or at least open sourced by Benjamin Vetter. And it's a great piece of kit. It actually has a relatively powerful microcontroller on it, the ARM Core STM32F4. And on top of it, on top of that, or at least connected directly to it, is a DRV8302 brushless DC motor driver. And this thing's actually designed for skateboards, so it's way overpowered for this car.
Does it support reverse?
Excuse me?
Does it support reverse?
It supports forward reverse. The Vetter itself will actually do encoder or coderless brushless DC motors. It's fantastic, and you can lock the rotors, and you can accelerate and decelerate, and actually kind of implement your own braking policy in that way. So I was very interested in this. It also has a tool. Again, this is designed for skateboards, but everything's open source. It runs GBOS. There's a way to, within the Vetter software kit, you can actually write your own plugins, or you can just completely replace it entirely. Using all of the examples, everything's pretty much available. I'm just using it in a UART mode, where I can just tell it, I want 1,000 RPMs, and I'll get exactly 1,000 RPMs. I want to ramp to 1,000 RPMs. Ramp to 2,000 RPMs. I can control that very finely. So, all right, coming back to my encoders, I looked at those brake calipers and they were sweet. So what I wanted was I could put my own rotor, or excuse me, my own caliper in there that actually had two photodiodes, and if I put an actual encoder wheel on the other side, this would work out well. So again, whipped out that desktop CNC machine, milled out some Delrin for the actual encoder holders and the actual PCBs as well, so a little bit of etching there. I don't do the etching anymore, I got kids. But in this case, it's for such a small piece, these little guys, I had to do them myself. I don't think you can send those off to Osh Park and get back what you expect. So these ended up being relatively simple to put together, but a lot of fine tuning. And again, on the back side of those encoders, I just used my favorite adhesive, Super 77. If you can glue anything that's not going to melt under this stuff, it's perfect. It'll stay on that piece of plastic, and it's always gummy, so if it ever flakes off or whatever, you just push it right back on. It's really good. And then again, I got to qualify everything. I got to make sure that what I expect, how I expect these things to perform actually do the performance. So I built a very simple rig just to get a sense of how close my encoder needs to be to actually read all of the pulses that I